Hi everyone, welcome to another episode of Living on Blockchain. Today we are speaking to Ian Smith. Ian is a veteran technologist and a force behind Quantum EVM. He has over 25 plus years of experience in more than 25 programming languages. He has deep roots in Web3 since 2016. Ian brings a rare blend of longevity and cutting-edge thinking to the blockchain space. We talk about the urgent need for post-quantum readiness and blockchain infrastructure, what it means to build an EVM that can withstand the next generation of cryptographic threats, and why developer ergonomics still matters in this post-quantum world. If you're curious about the intersection of the future of proof security, Ethereum compatibility, as well as long-term decentralization, this is an episode you would not want to miss. I can't wait for you guys to hear this. Let's deep dive right in. Hi, Ian. Thank you so much for making out the time to speak to me today. How are you doing?
I'm doing well. Thank you for having me.
It's a pleasure. So, for our listeners, can you tell us a little about yourself and your journey so far, how you got into Web3 a little quickly, and then we can get into the more media stuff, especially the work that you're doing, because it's very fascinating.
I started off in cryptocurrency in 2002, 6 years before Bitcoin. And I had a bad idea that I didn't release because it was a bad idea. And it was using cryptography in a different way. And you'd have to make change, and it possibly involved double spend. You had to be like online, and there was all sorts of like strangeness to it. And I attacked my own design and didn't release anything. I probably should have released stuff and just said, "Hey, here's a bunch of mistakes. This doesn't work. You know, maybe we should talk about it." Instead, I just said it's not good enough. When Bitcoin came around, I couldn't load my bag very well. I couldn't get the money to the exchange, so I didn't. And then I was just busy, so I didn't actually buy in when Bitcoin was 20 cents. When Ethereum came around, I jumped on the Web3 bandwagon very quickly, and when the Ethereum Classic split happened, I went on the Ethereum Classic side. So most of those people left and joined Cardano, and I was still on the Ethereum Classic side.
Okay. So post that, what did you do, and how did you move forward from there? Considering you said that most of these folks had joined Cardano.
I worked on making a chain for somebody else, and he ended up actually releasing the chain, and raised a lot of money on the chain. And I was digging through the Ethereum code and wondering why they were doing things the way they were doing them, and the variables the way that they named them, and why they kept making it so that the disks were getting hit so hard. And it just looked like it was really sloppy code. And this was 2016. From there, I just decided to just do consulting for people who wanted to do Web3 and didn't know what was going on. And I did that for a while. Did a few chain projects, but none of them actually got funding, even in 2019 or 2020, with under other people. And switched over to doing consulting work with some people I'd met along the way. And we had like a UNICEF client. We had Fiat blockchain doing NFTs on blockchain. And I've had maybe 50 or 60 Web3 clients, done all sorts of work in multiple languages on, I think, about 15 chains now. EVM being one, and then like Solana, a bunch of like Rust chains. So like Cosmos, Celestia, all sorts of stuff. And ever since 2002, I knew in the back of my head that one day quantum computers were going to be a problem. And throughout this, every couple of years, I'd check in again. I would see where things are going. And in 2023, there was a paper written, and I said, oh no, I'm late. We need to be moving faster. And I found that in May 2024. Started a project with myself leaving and flew, met partners, got funding a week later, and just started building. And we've been building for the last year.
Okay, wonderful. So, you have extensive experience, and now, you kind of mentioned how you always thought that quantum computers can pose risks to the blockchain ecosystem as a whole. So, can you tell me a little about that? What made you realize that it was a real threat, and how do you intend to tackle it?
Sure. So the problem is that a quantum attacker, and this is like people in a lab, and then later on it'll just be people running these at data centers, and then people running them in their houses. That's probably 10 years away before people can run them in their house. But whoever that attacker is, whether it's government or a company to begin with, they can just become anybody in the blockchain, whether it's somebody who's doing proof of stake, whether it's a bridge or a contract admin or your wallet. They can just become you and update contracts or remove funds or spend your money. And that is a problem with the underlying math. All of the blockchains have the same weakness because they're using the same family of cryptography. Even chains that brand themselves as post-quantum, like XX and Hedera and Algorand for now, but they're talking about fixing it. They're all possible. It's all possible to do the same thing. You can just become anybody in those networks, in Bitcoin and in Ethereum. Bitcoin has a little bit of resistance, but Ethereum and Solana are just going to get broken wide open. There'll be no protection. They're talking about protection, but they don't have any technology that they could use to protect the way that the transactions happen. So it's like there's a contract that you can use to protect yourself on Ethereum that uses these things called Lamport signatures. This is a really big contract and it's really big signatures, but it's quantum safe and it's put out by Poly Group. On Solana, they made something similar but weaker, and it's okay, but neither Ethereum nor Solana can actually perform transactions by the infrastructure. They're all it's going to be weak on both sides. Now, Bitcoin is proof of work, so it doesn't have that weakness the proof of stake systems have. And the other thing that Bitcoin has is this UTXO model. And what that means is that you're hiding your keys and your lock every time you send transactions. Your public key and your private key change, and they're hidden after a transaction. Whereas in Solana and Ethereum, everybody knows your public key, and the quantum computers can turn the public key into the private key. So the reason this became like now is because the hardware is kind of slow to get better. It's people say, oh, quantum computers are coming maybe in 10 years, maybe in 15 years. And for a lot of times they're talking about like retail, like where you can just go buy one at a computer store and take it home and run it. But a lot of people don't think that the hardware is going to catch on, or they don't think that it will work. And if they were looking at how many qubits, which is the size of the machine, would you need to break Bitcoin, and they look at the old numbers, the number is billions. It's billions of qubits from the numbers in 2020. And then in 2022, it was like hundreds of millions. And then 2023, it was just a few million. And that's where things got scary. And this year, now it's a couple 100,000. So if as the algorithms continue to improve by 10 or 100 times performance every year or two, then the time in which we have to prepare goes down really fast, even if the hardware was staying still. Even if the hardware had no improvements, aside from, being able to run some programs, then within a year or two, the quality would be good enough to run some programs, and then the quality would get better. And even no qubits per lane, we're getting the ability to plug in lots of these qubit machines together, and they all share, as opposed to silicon. Silicon doesn't go faster the more you plug in. It goes a little bit slower for each additional machine. Quantum computers go faster for each additional machine. And there's a point in which your normal computers don't really contribute much anymore. You add another machine and it's only a very, very slight improvement, because everybody has to talk to it, and there's tons of network messages, and they're all going back and forth. So when I was in Silicon Valley in 2000, I worked on high availability and clustering. And these are fancy words that mean making lots of computers do one task. And there was this threshold that you eventually hit where it slows down. If you look at blockchain, the proof of stake systems, they don't have many machines if they're using one architecture. And the other architecture, like Solana and what Ethereum switched to, you can have as many machines as you want. It's using the same cryptography as Solana, or as a Lightning Network. And it turns all of the work done by all of those cryptography transactions into one signature to check. And for the block, there's only one signature to check, no matter how many machines there are. But even though there's only one piece of work to do, if you have too many machines, you're talking more than you're working. Quantum computers, every time you triple the size of the network, it goes 7 times faster, which is a huge, huge shift. So even if the quantum computers didn't get any bigger and you just were able to plug them in and make them, then we're going to have a problem, because they're going to be able to break Bitcoin, Ethereum, and Solana in a few years, because the algorithms allow them to do work much more effectively. So it's really scary for everybody. And, there's a bunch of people saying, oh, it'll never happen. Saylor was one of them. He said that the only threat to Bitcoin was space aliens. And, the people who hold his Bitcoin just said no. Last week, they said, hey, quantum computers are a risk to blockchain, and they can take the Bitcoin right out of our fund. And so it's going to be an interesting convention in Vegas, because now there's going to be reality checks for a lot of people. This is a real problem. It's hopefully still, at least 3 years away, but I'm afraid it's not.
Right. So you paint a very grim picture about, and as you said, that, it's becoming more and more clear that this is going to be a reality sooner rather than later. So for those who are perhaps a little less familiar, can you tell us a little about post-quantum cryptography? Because you've already kind of mentioned how vulnerable today's blockchains are to these attacks. But if somebody doesn't necessarily understand post-quantum cryptography, can you shed some light on that? And then perhaps we can get into particular areas which are more vulnerable in this space to these attacks, or they are at a higher risk.
Sure. So your elliptic curve cryptography is a big prime number. It's a number that you can't divide and get a smaller number. It's one very large prime number. And your private key is the number of times that you multiply that big number by itself. It's the exponent for this big number. And you're just looping. And then there's a bunch more math, but the security of this system is just this one thing. If you can find out the exponent, then you have their private key. And so it's like this gigantic number that doesn't get too big because when you multiply it, because it's just a loop. It's not, it's not the result of everything. It's just like a clock. So post-quantum cryptography uses completely different math, and it's really important that we use different math. So the layman's explanation that I have for crystals dilithium 5 is that if you were to cover every single planet and every single star in the entire universe with grass, and then find 2 matching blades of grass, then that would be a way to find the private key. We can actually do this if there's not that many blades of grass. But when you get a lot of them, it becomes much, much harder just by adding, one more decimal place, or one more, if it's 10 times bigger, you have to do like 100 times the work. So those keys have to be large. They're like 1,000 bits or 1 kilobit. Excuse me. So with the keys normally around like 1 kilobit, they're safe. And this is a giant matrix of numbers. And in order for you to sign a transaction, you're signing the same hash that you do under your cryptography today. It can be KEKAK, it can be SHA-256. Those are safe. And those are going to stay safe probably for another 15 years. The soonest we could possibly break those would be about 15 years at 256 bits. If they're smaller, like Ethereum's, it's 160 bits, then they're going to become vulnerable more quickly. This is paraphrased, it's not quite right, but if you were to take all of the hash power for all of the Bitcoin network, and you were just trying to find a duplicate address, this is the paraphrase part, we'll say it's just a duplicate hash, then at 160 bits, you have a 55% chance of actually coming up with the duplicate address. The more precise version is that you're doing a birthday attack, but you need to have a matching private key for the hash. And so each calculation is more work than just the hashing that you're doing at the end. It's a lot more work. But those are 2 areas that were weak to quantum computers. The first one is the hash sizes need to go up. You can't use 160 anymore. You have to use 256 bit bit hashes. And the second is that you have to use this like a giant matrix block of numbers that people are drawing little, what they call vectors in there. And the security is not discrete logs, but it's the shortest vector problem. There are other forms of post-quantum cryptography. One of them is like, imagine you're playing a game of telephone in a school, and all of the kids, like 1,000 of them, are arranged in a ring, and every kid says the number to the person next to them, and they always get it a little bit wrong. And that is similar to a post-quantum cryptography called ring learning with errors. These are layman's approximations of them, but you could kind of picture the problem in these ways.
Right.
For Quantum EVM, we took all of the weak cryptography that is going to be broken by quantum computers, and we're replacing it with the new cryptography that is secure against quantum computers. We made the address size of the wallets in the EVM, like in Ethereum, to the full 256 bits instead of having the addresses of the wallets only being 160 bits. So we're upgrading everything, and we're making sure that there's no weak cryptography anywhere in the network. So it's quite a bit of work. Particularly because the code is still slow, and they have lots of ways of programming the same thing, and none of them work quite right.
I think that
there is.
good.
Go ahead.
Yeah, I was saying that you can finish your thought. I said that does paint like I said, a grim picture, and that gives us a good idea about what post-quantum cryptography is. But please go ahead, finish your thought, and then I have a follow-up question.
Go ahead. I think I might be answering your follow-up question next.
Okay, so my question was that how is quantum EVM say different from a ZK based solution? I think drawing that analogy, because I understand that they are very different technically, but not everybody would be tuning in would be that technically sound. If you could draw some comparisons there, I think it'll really create a cohesive picture of what you guys are building.
Okay, so we're a layer 1, which means that if you just were to take Ethereum and not like all the rollups or all the ZK or all of the things that are built on top of Ethereum, we're going to be Ethereum, but post-quantum. Right. And you can still build similar things on top, but the problem is that there's a flavor of ZK that's safe, and there's a flavor of ZK that's weak, and nobody uses the safe version. The weak one is called a snark, and it uses the same elliptic curves inside of it. And the strong one is called a stark. And there's even a company called Starknet. And Starknet does not use Starks in their network. They mislabeled a whole bunch of things. SUI, SUI uses a lot of different ZK technologies for doing some really cool and really fancy math, and they've created some amazing products based off of how using ZK in different ways. It's all going to break. They don't have a replacement. They're talking about hiring a whole bunch of math students and saying, please help us. There's possibilities that they might be able to fix or create a new infrastructure in time that does the same thing. But we can't really scale up with these layer 2 solutions because the way in which we make it cheap to solve a lot of transactions and the way in which we have a lot of people join a single network, both of those don't have a post-quantum variation. There's no post-quantum multi-party computation, and there's no post-quantum good signature aggregation. In other words, you can't combine them all into one and just check one. We are going to support ZK Starks a little bit. The problem is that nobody's using them. And we are going to support something called fully homomorphic encryption. And this is like a spreadsheet that you could do math on, like add 10, subtract 10, but you don't get to see the spreadsheet, but you still do the math correctly, and you can still demonstrate that the math was done correctly, which is a really good privacy feature. My biggest concern for ZK is that it's broken in lots of ways, not just a few. It's also broken now. There's papers on my Twitter that I posted links to, and I'm telling all these ZK people, you need to make sure you're not doing this, because if you are, people can prove false statements. And that's going to be also true in the post-quantum era. People could construct a statement that isn't true, like, I've got $1 million. And then they can show that statement to a prover, and the prover will say, oh, yeah, you have $1 million. We'll buy that product for you. You're like, okay, I'm a millionaire now. And that's possible to do that break today. So that's a problem with the ZK architecture today. Not every ZK is vulnerable. It's just how they coded it. But yeah, the other thing that is going to be a big issue is if you put your passport or your driver's license into a ZK and you're like, it's a secret. Well, it's a secret today, but it's not going to be a secret when quantum comes. So if there's long-term value in any of those secrets, you've exposed yourself long-term, and that may bite you in the future.
Okay. So can you, I'm sure that this has got a lot of people very intrigued who will be listening in. So can you tell us how compatible is Quantum EVM with the existing EVM-based contracts, and or how is easy or hard is it to migrate?
So we're aiming for a 15-minute migration. You should just be able to hit compile, and then after you've downloaded our wallet, with our wallet, you hit publish, and then boom, it's on chain. And then you take the address, which is going to maybe be the same size for smart contracts, and you're going to put it in your website, and you're going to put a Q in front of web3.js. So it'll be QWeb3 and QHardHat, and we have to change the math and all of these libraries and all of this stuff to stay compatible. And we're aiming for as much compatibility as we can get, but there's one area that we're kind of stuck on, and it looks like the compiler is, we're trying to not change it so you can use any compiler that you want, but it's being really painful. I'm really hoping that we don't have to change the compiler, but it looks like you can't, like if you have a wallet address or a contract address currently hard coded in your wallet or in your contract, then you're going to have to make it a variable and then assign it after it's been compiled. And I think we can support that. Let's say that somebody had a token or an NFT that's sitting on Ethereum or Base, and they want to go to quantum safety. So they recompile the contract, they publish it, they're done in 15 minutes. And their users are like, well, can we move our tokens? Because I bought, 1,000 of your tokens. Could I move those tokens over to quantum safety? And the answer is yes. We have a library that will allow them to burn the tokens on the current network. And then when they've done that, it'll mint them into the quantum safety. And this is, the library gives this extra mint function that requires the burn to match, and the burn needs to be signed. And the signatures are only valid if there's no quantum attacker, because that other chain, you can't trust it once they can break it. So the migration should be done before the hardware is ready to go. If the hardware is ready, well, we shouldn't do that anymore. We should turn off any kind of like conversion or migration. And we'd say, well, you can rebuild your business on our chain, but you can't destroy the value of our chain because your old one is dead and it's worthless. And we don't want to bring chaos into our chain. We want to keep our chain valuable and secure.
Okay. So again, for folks who are perhaps very intrigued by this and they are looking to or willing to try out Quantum EVM, how can they go about doing it? What are the kind of milestones that you're looking at vis-a-vis the product in the coming days?
So by the time that this is published, I'm hoping that we're going to have our testnet live. If
Okay.
not, it should be very shortly after it's published. Like I said, we're fighting to make this easier for everybody else, and it's a hard fight. The things that we're doing, they're hard, and I'm just hoping that we can fix the things that Ethereum has failed to fix. They gave up on fixing it. So we have quantumevm.com, and you can check for news there. But I talk, and so does some of the team inside our Telegram, which is linked from our quantumevm.com. But if you just want to type the Telegram directly, it's t.me/quantumevm. And we have a Discord, and we have a link tree, and we have X, and they're all Quantum EVM with no space. There's a bunch more links like YouTube and stuff, and there's like gaps and spaces in some of these, like Instagram and YouTube. But we have a lot of more technical explanations, and we also have a growing library of news articles and explanations. How does this work? How does it break? What's the risk? When is it going to happen? And I found that after going to a couple of conferences, that everybody has a different personal journey, and they want to have the questions in their head answered. And you're welcome to join and ask. And some of our community members at this point can answer them. And if not, I can, try to answer them.
All right. Okay. Thank you for sharing that. I'll sure to link, these up in the description of the episode as well, so that our listeners can actually get quick access to these links and they can post questions if they have any and read all the technical documentation. So, while you were talking, it just suddenly struck me that there is something that I had read about somewhere, I think on Reddit or Hacker News, I'm not sure. And it used the term harvest now, decrypt later. Right?
Yeah.
So
Yeah.
can you tell us a little about that? And I think that would be something that would fit right in very well in this particular conversation. And can you talk about how it's a silent threat, perhaps?
Sure. Like the ZK, if you're putting your license on chain now, they can they can just go download the encrypted copy of your license or your passport that's protected by ZK. And once they have that copy, they can't break it yet. But when the quantum computers come around, they can break it. And so they're harvesting the encrypted copy of your passport, and then they're going to decrypt it later. So I've seen like harvest now, crack later, and also harvest now, decrypt later. But this is especially true for like instant messengers and so forth. So Signal and Apple Messenger and Google, a couple WhatsApp, they've all already upgraded because they know this is a threat to the privacy of everybody that's using those systems. Have the people making ZKs upgraded? No. And that's a problem. They need to switch their ZK architecture to at least using ZK Starks, but they haven't. So I'm really hoping that the ZK people will wake up to the damage that they're going to cause to their users from the harvest now, decrypt later, if they're keeping any secrets. Now, public keys, like you look at a blockchain, there's this record of all the public keys that have spent money. If you've spent money, you spent it with your public key. And they can harvest your public key now and then just crack them in batches later on. The batches that were proposed in 2023 was 4 at a time, but it costs the same amount of time to break one as to break 4. And the only cost to break more is having a few more qubits ready to store the question and the answer. So they can be doing batches of 100 and just cracking everything and finding out what they get. So harvest now, decrypt later doesn't matter if you're famous or if you're unknown. They can just batch mode the whole thing and break all the secrets and then find out what was juicy, find out what was valuable afterwards. In case of blockchain balances, well, the blockchain exposes that, so they already know if it's worth taking your wallet money. But they're going to go for identity theft and like ways of framing people and laundering their money and all that stuff too, which means all of these ZK architectures.
Okay, yeah, this is good. I think this will again make it a little easier for people to digest what we are talking about, because both of us have to agree that this is highly technical stuff that at times people don't want to really get into it, right? They don't want to spend the time to understand why this is important, and I think that is why that kind of underscores the importance of it, and it makes it perhaps your job a little harder, would you say, for because you have to you have to educate people as well, and devs as well. I would think, because there are people stuck in they think in a certain way, and there is a certain loop to their thinking, so they don't believe that this is a real threat yet. So how are you making sure that what you are creating, and when you go out with the test net, that actually devs and users are able to take it with the utmost seriousness? How will you go about making that learning curve a little shorter or smaller? What kind of efforts would you be putting in that direction?
So I go to conferences and speak, and I'm saying like, look, I don't want to pay money to speak because I'm just trying to save everybody. And some of them are saying yes, and some of them are saying no. But I don't want to spend like $1 million of money I don't have, paying to go to all of these conferences and giving these presentations on the main stage. So it's education. It's really a hard education problem. In one of the other places I'm, trying to do education is on podcasts, and we're going to be putting together a couple documents because BlackRock actually acknowledged through their legal filings with the ETFs that this is a serious threat and a serious issue. I've seen scams popping out everywhere. So, and this is just in a few days. They're just popping up all over the place. We're post-quantum. No, you're not. We have a thing that if you just send us your Bitcoin, it'll be safe. No, it won't. And I've seen this everywhere, and it's really scary and really dangerous. So I'm constantly fighting scams on Twitter, because my concern is, let's say that we do all this post-quantum cryptography, and I'm aligning with I have an alliance with QRL and with Cellframe and with Mochimo, because they're all post-quantum cryptography also. We're doing different things, and we have different niche things. I'm doing EVMs, right? But we're all post-quantum. If we don't do the majority of the marketing, then everybody who's looking for post-quantum solution is just going to get scammed, and they're going to get their money stolen. And there's, if you look at the total value locked, like how much money is sitting there, it's like 5 trillion. And $5 trillion is a lot to lose, especially when you consider some of that's banker money, some of that's retirement money, and some of that's stock money. So I have this overriding urge to expose scammers, because if we don't, then we're going to have a financial crisis. We're going to have a crash. I'm also working to try to make Bitcoin safe. I'm going to be in Vegas. We're having a post-quantum proposal that's different than the one that is done by BIP 360 and Hunter Beast. I support him. I think he's got a good idea. I don't think that leaving 6 million Bitcoin for the first person to steal them is a good idea. I would want to protect the value of Bitcoin. And I did the math, unfortunately. I looked at the how much buy volume is out there. And I found basically 4,500 Bitcoin of pending buys, and then the price would drop about 18% in order to to sell just 4,500. There'd be this big spike in one bar, and that's really scary. So when I talk to people, one of the problems is all of the bad information that they've heard. They're like, quantum computers will protect Bitcoin. You mean hashing and mining? No, that's years after they break it. The Bitcoin protocol, so the Bitcoin old exposed wallets, those get broken first. It's easy. After you can do it fast, then you're able to take money out of people that have no exposed public key, but they just submitted a transaction. And they could take the money before it's mined, do replace by fee, and then the money goes to the attacker and not to the intended destination. But they have to solve it in like an hour or two, or 10 minutes, depending on the network. The fees and the network time. And that's what the paper in 2023 targeted. They're like, here's exactly the size of the computer that we need to break Bitcoin in 10 minutes. Multiple keys each time, which means that every time someone spends money, all of it goes to the attacker. About 2 to 4 years after that, when you can buy one at the store and take it home and run it without having liquid helium, well, that's when you can use it for mining. That's when you can use it to secure the chain better. And it's years afterwards. Bitcoin, it will have been dead for several years if we don't do our job protecting it now. If we can't protect it now, there won't be any Bitcoin worth, Bitcoin's value will be like under $10. And then you'll be able to mine Bitcoin with your quantum computer when Bitcoin's like, $5. Sure. So they don't understand the time scale and like what problem is harder. It's easier to steal your money than to protect your money with quantum. One of the other horrible mistakes people make is like, well, the banks will die first. No, they've already upgraded. They're already using post-quantum cryptography. Maybe not every single machine, but you'd have to break into the bank network using some other technique that isn't quantum computers, find a machine that hasn't been patched to the latest cryptography, break it, and then write a whole bunch of custom code to try to take over the bank network from there. And the reality is, if you can do that, then you can just steal money from banks already. You don't need the quantum computer because you've already broken into the bank. You're already, digging through the bank internal private network. All the communications between banks, it's already upgraded. All of the communications between you and the bank, already upgraded. Anytime you see the keys spread around, that's when there's an ongoing kind of semi-persistent risk. And that includes the payment terminals and the ATMs. Those are situations where if a quantum attacker is able to read the fiber optic line coming off of that ATM, it will matter to you. Some of them do have phone cables, but a lot of them are using what they call dark cables, and some of them are using fiber optics, which is light cables. But they have to get the data from between the ATM and the bank in order to know what the key is to crack. So it's like another challenge. They'd have to be physically present in order to get some of that data or take over the entire telecommunications infrastructure between you and the bank. And that's very hard because they protected that. They made it a short loop. It's a direct phone line in many cases, and it's encrypted. They'll be able to break the encryption, but they really don't need your $1,000 or your $500. What they can do is they can go get $600 billion from Bitcoin. One of the other things is going to be an issue, and this is partly why there's such a big race, is that when missiles are chasing planes, they make sure they're not going to shoot down their friends. And it's using the exact same cryptography. So if you can break Bitcoin, you can also break the missile. And the missile will think that you're a friend, even if you're not. So whoever does this first, they get to make their planes immune to enemy missiles. So one of the hopes that we'll have more time is that the NSA or China may be more concerned about missiles than Bitcoin. China said they're going to destroy Bitcoin. They have to destroy Bitcoin, so they might do Bitcoin, then Taiwan, and then or Bitcoin and then missiles and then Taiwan, but maybe not. In the case of the United States, the NSA wouldn't really be allowed to destroy everybody's retirement account in the stock market. So if somebody makes one of these machines and they're working with the NSA, they're not going to really be allowed to break Bitcoin, like right away. But there's 45 companies racing to do it. So it's going to happen at some point. It's just the question is when.
Right. So for folks who are perhaps, intrigued by this space and they want to understand quantum computing a little better and how they can perhaps build better, there are so many entrepreneurs and builders who are working right now. What would be the kind of suggestions that you can give, or any recommendations of resources that you can give these builders, Web3 builders, so that they can really do this right and they can build whatever they're building, keeping the next 10 years in mind?
So Self-Frame is a great architecture to build on. It's scalable, and it's the only scalable post-quantum, and we're working with them because they will help us scale up EVM in a post-quantum era. The post-quantum, anytime you see a chain says they're fast and post-quantum, they're lying. They're either not fast or they're not post-quantum. We can make it scale, but it's by having lots of shards. So you could build a custom shard on, QEVM if you want an EVM, or if you want to do something deeper, you can build on Self-Frame and you can do sharding on Self-Frame and run a shard. There's a company that's doing printed circuits and 3D printing and manufacturing and all kinds of hardware stuff. And they're just using Self-Frame as a communication layer, and their entire company will be post-quantum as a result. We're doing DeFi on Quantum EVM. We're going to have we have a project that we signed contracts with called LynxCap, and they're doing 10 or 11% yields per year. So we're going to have a DeFi infrastructure that's really appealing to build on top of. And the reason that they're doing 10 to 11% a year is because they're buying real estate and taking that real estate and fixing the bad loans. The banks have to sell them the bad loans; they can't keep them. And they fix them up, and then they either have the property to sell or they have the income from the people paying their mortgage. So that's that plus a DEX and a couple other things. That's infrastructure to build on top of. And we could have tons of builders build on top of QEVM, and that would be great. We're going to have shards for supply chain, for DPIN, for RWA, and links cap is like an RWA asset that's yield bearing as opposed to just tokenizing things. If you're doing RWA, you really need to ask yourself, will this asset be around when the blockchain isn't? How do you mitigate against that? One is, well, build on post-quantum cryptography. Advice for builders, like everybody who's doing programming should learn what the accepted post-quantum cryptography is. And there's different kinds, and they're very different from what you're used to. Very different. For example, elliptic curves can handle both SSL and fixed messages. In post-quantum, you have to use different technology for each. SSL, or like a session that's encrypted, is KEM, key exchange mechanism. And signing a fixed message is a digital signature algorithm, or DSA. And that's like crystals dilithium. There's also a whole bunch of other things like XMSS and Sphinx Plus. You shouldn't use Sphinx Plus for blockchain. One company just found that out the hard way, and they have this post-quantum cryptography, and now they can't do any transactions because the signatures are 50 kilobytes. It's just too big. So it's important to understand these technologies before you make the same mistake that they just did. I mean, that just burned millions of dollars and tons of investors because they picked the wrong cryptography to build on top of. If you can't build on top of somebody else's work, which that's what layer ones are for, then you should definitely study this well before committing to any cryptography or any architecture. Some people say Falcon is post-quantum and NIST approved. No. It is not approved, and it is so weak that you can break it with computers today. So you need to be careful on Falcon to make sure that you're going to use a version of Falcon that is safe, because the versions that are in use right now are not safe. If you're a builder, yeah, you gotta pay attention. You have to read papers. You have to read a lot, or ask people who've gone through all of that pain and read 100 doctorate level papers on math, so you don't have to. I'm willing to help anybody who's building post-quantum technology in Web3, as long as they're actually building post-quantum cryptography. If you're, if it's a company that's going to just claim that they're post-quantum, we're on opposite sides of that battle, and I'm gonna make that painful. So if you are a builder, make the right choice. Protect your users. Go post-quantum. Feel free to ask for advice. If you're a scammer, beware.
Okay. So, is there any starting point that you would recommend to these guys in terms of any paper that they should be reading first so that they can get a hang of it, or is there any book that you would recommend? And how are regulators reacting to all of this? This technology that is evolving at the moment. Have you observed any kind of response from governments and institutions?
It's the law. You have to switch. It's already the law. Now they're talking about making the switch, the current deadline for when you're no longer allowed to be on the internet. They're talking about making it sooner than 2030 or 2035. Like Australia has a law, United States has a law, EU has a law. You have to upgrade. UK has one. You have to upgrade. That includes blockchain. You're not magically able to use bad cryptography and still be legally compliant. So it's really dangerous if you partner with a chain that claims to be post-quantum and they're not, because you're technically breaking the law by proxy. So if you have your business and you're registered and you're following the rules and you're using bad cryptography, in 5 years you'll be breaking the law. So the other thing that the regulators are doing is they're giving recommendations, and the NSA has recommended do not use old cryptography for any new projects starting in 2025. The White House in the United States issued an executive order just before the presidential change, saying that you had 90 days to upgrade, and it's just not realistic. It'll take more than 90 days. They had this like planning and implementation kind of like vagueness, but they were trying to force everyone to upgrade immediately. Is that a warning that we should pay attention to? Maybe. I don't know, and I don't want to wear a tinfoil hat, but it's creepy. Financial Services Authority in England and I forget their twin in the EU. They're really talking about cracking down on this, but they're not able to do policy. They're only able to give advice. It's the lawmakers that decide what the law is, and not them. So there's laws on the books now. You're going to have to upgrade.
Right. Okay. All right.
Book.
Yeah.
There's no good starting book. The best thing you can do is read the NIST recommendations and ask people who've gone through the hell already.
Okay. I'm sure that a lot of people would be DMing you after listening to this. You really curtail the threat. So, Ian, I completely lost track of time, and it's already like we've run past the deadline that we had. So I'll ask you two more questions before we wrap this up. One question is the penultimate question is what does success look like for Quantum EVM, say by 2030, in the next 5 years? How would you define it? And then we can do the ultimate question before we wrap up this recording. This has been very, very insightful. You gave me a lot to think about.
So we're Noah's Ark for Web3. So if enough people get on the boat that we can rebuild after the crash, then we've been successful. If there is not a financial collapse from Bitcoin being broken by the efforts of people who are trying to fix this, but aren't getting enough attention and enough, like Bitcoin right now, everyone's talking about op return, and no one is talking about post-quantum until the ETF change. So we're kind of a little scared that there's going to be a financial crisis worse than 2008. And if we can avoid that, even if it means the crash of Ethereum and Bitcoin, if we can avoid the crisis that destroys governments and banks, that's a partial win. If we can save Web3, that's a great win.
Right. Yeah, I think, you have like a formidable vision. But, I do want to go to my ultimate question, but I do have another thing. How do you stay committed to, how do you stay motivated, perhaps, is the more right word? How do you stay focused and motivated and funded in the now when you are building for a threat? There's so many people are underplaying at the moment, and they feel it's not going to perhaps fully emerge in a decade, and obviously you feel that time span's going to be much less. But how do you stay committed, and how do you stay motivated, I think is the better word, to building on this?
I work between 80 and 130 hours a week, pretty much every week.
Right.
And that it's 80 if I get a day off, and I get a day off about once a month, sometimes once every like month and a half. The motivation is mostly nightmares. Yeah, I've done the math. It keeps me up at night. It wakes me up after sleeping for 3 or 4 hours. So it's a great way to stay motivated. Just, dreaming about what's going to happen and feeling helpless to prevent it unless I work harder, convince more people, show what's going to happen, do the math.
Knowing the threat, basically, I think is enough. you understand it well enough, so that kind of keeps you committed, I would imagine.
Yeah. And I read the papers that show how close we're getting. And then I have, more nightmares after reading a few papers. And
Right.
I get my motivation is coming from all of their successes, right? The attacking success keeps me motivated.
Yeah. Okay. Wow. Like I said, this has been a very, very insightful conversation. I think even I have been on the other side of the fence where people, I'm one of those people who thought that, okay, this is going to happen, but it's going to happen in some time and we have time to figure this out. Clearly, after this conversation, I understand that's not the case. So we need to be looking at it right now, and we need to be mitigating and trying to reduce the kind of impact that something like this can cause on the existing system. So, like I said, you've given me a lot to think about. But because, sadly, we're out of time, I need to ask and pose the last question that I ask everybody who comes on the show, Ian. I ask everybody, to give me their 2 cents about how they would want people to truly start living on blockchain. What will be their suggestions? So here for you, I'll twist it a little bit. I would ask you, what would be your 2 cents for people and builders so that they can truly start living in the post-quantum cryptography world?
Well, switch to a layer one that has post-quantum cryptography, or build a layer one and compete with me. I would be happy if we have more migration targets for people to pick, so they could use like a Cosmos Rust WASM, or they could use a SUI contract and move. I would love that, because we need to get more people migrating and preserve more value. The way to get, I think, people to use blockchain in general is stop doing token sales and start doing product sales.
Yeah. 100%. I totally agree with that sentiment. I think that is something we talk a lot about on this podcast as well. So once again, thank you so much. I'm filled with gratitude for the conversation, and I wish you all the luck, Ian, for the upcoming testnet. I would love to try it out and test it out and see how I can ensure that the products that I'm working with can switch or at least try to mitigate to this technology, this platform. And any parting words before we wrap this up?
Thank you so much. Please get on Noah's Ark. We need at least 2 of everyone.
Sure. Yes, I'm going to do that. Right away. So
thank you so much.
Thank you so much once again, Ian.